Section 6, Video 3. We're going to focus on this question here because it involves a couple more steps than we've seen so far. The first thing we want to look for is it in standard form? If we're going to use elimination, both equations must be in standard form. And this equation is not. So I'm going to have to subtract the 3y from both sides. And that will give me a new equation, and it will be 2x minus 3y equals 11. I now have my second equation. I'm just going to move it over here to be underneath the other one. So now I have accomplished the first part. They're in standard form. Now I look for opposites. I have the x's have a 2 and a 3. I can make them both into 6's, but they have to be opposites. I'd have to make sure one of the equations is negative. The y values have 3 and 2 also, but one of them is negative. Again, I could make both of them 6's, so they cancel. Both of them require that both equations be changed. Again, for efficiency, I'm going to choose the y values because they're already opposites. One less thing for me to worry about. So I'm going to multiply the top equation. So the least common multiple for 3 and 2 is 6. So because they're already opposite signs, I'm just going to have to multiply the top by 2 and the bottom one by 3. And that gives us two new equations, equivalent equations, but more suitable for elimination. If I distribute, I get 4x minus 6y equals 22. I distribute the 3 to the other equation. I get 9x plus 6y equals negative 9. Now we've accomplished our goal of having opposites. So if I add them vertically, they cancel. We're left with 13x equals 13. Divide by 13. X is 1. Again, we're looking for a coordinate, and we've just found the x. Again, I end up solving for x all the time. You could very easily solve for y. That does not matter. So now I have a variable for x. I have a decision to make. Where do I plug in my x value? I could plug it into this one, either of these, or either of these. Does not matter. You'll get the same answer either way. For kicks, I'm going to choose the very first one up here, and I get 2 times 1 equals 3y plus 11, so 2 equals 3y plus 11. I subtract 11, and we have 3y equals a negative 9. Divide by 3, and y equals negative 3. So again, we're looking for a coordinate, and we just found our y, and it is negative 3. That is our solution for that system of equations. So this ends Section 6, Video 3.